at water and you want to find the enthalpy of the water, just type in Google the enthalpy table of water at different temperature, and this will come up. So we will have pretty much same values. But if you look on this side, if you look on this side, the values are given in here. The values are actually given at 10, 20, 30, 40, 50, and so on, all the way up. There's more, but I just stop at 140. Now it's from 0 to 374. In the question, it was 6 degree and 18 degree. So how do we do at 18 degree and 6 degree? So what we do, let's just make that thing a little bit bigger. So I want to find out 18 degree and 6 degree. So let's do at 6 degree. Now here you can actually see, let me make this thing bigger. So here you can actually see at 0 degree, like 0.01 degree, 0.01 degree, this is temperature. The enthalpy value, the H value is 0 in kilojoules, yeah? So it says here, yeah? So that's in for 0 degree, 0.01 degree, it's that one. So we just look at the enthalpy value here. Now this is kilojoules per mole, but if you look here, that's kilojoules per gram. So we are going to use that value rather, kilojoules per gram. Yeah. So we're going to use that table and that table. So it's going to be 0.000612. And when the temperature was 10 degree, when the temperature was 10 degree, the enthalpy value was 42. So enthalpy value was 42.021 kilojoules per kilogram. The unit here is kilojoules per kilogram. Okay, so I can multiply by 1000 if I want to. I don't need to. So what does it mean? It means for 10 degree, this not exactly 10. So the temperature, when the temperature increased from 0.01 to 10, how much temperature has increased? Let's find the difference. 10 minus 0.01. Yeah. So which mean if I increase the temperature 9.99 degrees centigrade or Kelvin, same thing. Yeah. The enthalpy increases to the value of the enthalpy increases from that to that. So let's find out how much is increased in enthalpy. So 42.021 minus 0.000612. So 42.02, 42.02, 0388 for 9.99 degree, which means for 1 degree, how much will be the increase? I divide both sides by 9.88. Yeah. So I'm going to divide this thing by 9. Did I say 88? 9.99. So whatever answer I got, divide by 9.99. For 1 degree, the change is going to be 4.20625. Yeah, we usually write it to 5 or 6 decimal places. Okay, now the temperature was 6, so I don't like 1, I want 6. That was the temperature at the outlet, isn't it? So I need to multiply that by 6, because if I want to find that as 6, multiply that by 6, multiply that by 6, so times by 6, the answer is 25. So at 6 degree centigrade, enthalpy is 25.23747. The units are same as the unit given here, kilojoules per kilogram. Yeah. Now the next bit we got was 18 degree. We need to find for 18 degree. So now we need to do the calculation for 18 degree. So 18 degree, I am going to use from 10 and that one. Yeah, these two values. So
Is that because it's not consistent?
yes, yes. Even though the answer we're getting are approximation, but it's a lot better than taking the whole. So we take every 10 gap because the curve is getting might be steeper or less steeper. So not consistent. Yes. Okay. Now let's say I want to find the enthalpy of the water. I want to find the H of the water at 18 degrees centigrade. Or yeah, 18 degrees centigrade. So because that's all in centigrade. So how I do? I'm going to use I'm just going to use this one, 10 and 20. And oh, sorry, I just select the wrong one. It's not that one. It is that one. Thank you. Yep. So at 10 degrees centigrade, the value is 42.021. At 20 degrees centigrade, the value is 83.914. And I need 18, which is going to be more closer towards here, isn't it? It's far away from the 10, close to the 20. So I need to find that one. So what I'm going to do is 10 to 20, that's 10 degree. Yeah. So if the difference is 10 degree, yeah, Celsius, that means the difference between these two is going to be 83.914 minus 42.021. Difference is 41. So 10 degree mean 40. I'm not going to put degree. 10 mean 41.893. And I want to find what's the difference for 1 degree then. 1 degree, divide everything by 10. So 4.1893. Yeah. So I just move the decimal here. Divide by 10. Now I want at 18 degree. I want 18 degree. Yeah. So which means if I multiply that by 8, not 18, 8. Multiply that by 8. Why multiply by that by 8? I tell you in a minute. Multiply that by 8 and that by 8 as well. So if I multiply that by 8 times by 8, the answer is 335. No, why 335? Because I forgot by 10, yeah? Divided by 10. 33.5, yeah? 33.33, sorry, my maths is not very good. 5144, yeah? So, yeah. So we got this thing. Now this is at from 10 add 18 add 8. So I want at 18 degree. I want at 18 degree. So 18 degree is going to be whatever value 10 degrees plus the difference you calculated at 8 degree. So 10 degree value I don't know. I will go back. Is that 42? I write 42.021. And the difference 8 degree I just calculated 33.5144. So that will give you 75. Which means I can go here and I can write, yeah, or 5354, sorry, 5354. Yeah, so it does sound good because 42 is at 10. That's by the way 10, and then as you move down, it increased. Yeah.